Hello friends, welcome to the next lecture in this series of cosmological perturbation theory. In this lecture, we are going to look at how does a tensor quantity, which is a tensor of rank 1, 1, this form, how does it transform from gauge 1 to another gauge? So in other words, we have this tensor, this perturbation in F alpha beta in gauge 1. Remember that in the beginning of the course, we described gauge 1 with the caret on top, and then later after we formulated some helpful equations to simplify the notation, we decided to drop caret. So a perturbation without caret is in gauge 1, and the one with tilde on top is in gauge 2. So we want to see how delta F alpha beta in gauge 1, tensor of rank 1, 1 in gauge 1 is related to delta F alpha beta tensor of rank 1, 1 in gauge 2. And in the last lecture, we looked at how perturbation, which is a tensor of rank 0, 2, that is alpha beta or both on the lower side, how does that type of tensor transform? We looked at it in the last lecture. We derived this equation, this one, for a tensor of rank 0, 2, and then after that we extracted 0, 0 component, 0i and ij component from this equation. Now we'll do the same exercise for rank 1, 1 tensor, and then we will compare how the results look like in comparison with the equations that we have formed for a tensor of rank 0, 2. Our starting point is, let's go to our review sheet. This is a review sheet which I am making, and somewhere in my future lectures, in one of my future lectures in this series of cosmological perturbation theory, I will share this review sheet with you, and you see that it contains all the helpful equations that we need in order to solve the problems. We'll start with this important equation, that in a given gauge, how the values at p tilde and p caret are related. And you see that they all have the same form, and we looked at this equation in one of our previous lectures. We derived it, and we came to conclusion that all these equations, they have the same form, that is in a given gauge. Let us say we are in gauge 1. So in gauge 1, value at p tilde is equal to value at p caret minus partial derivative with respect to gamma, in the partial derivative of the background value with respect to gamma multiplied by xi gamma. And all of these equations, they have the same form. For example, if you look at the scalar, so scalar value in gauge 2 is equal to scalar value in gauge 1 minus partial derivative with respect to gamma at a point in the background FRW multiplied by xi gamma. Okay, so let us grab this equation and bring it over here. And also, okay, so we can write this as So value at p tilde is equal to value at p caret minus partial derivative of the background at gamma multiplied by xi gamma. And I can simplify this by the notation. It is obvious that we are looking at the background value, so I can remove this p from here. Okay, next we can write the equation which we said is the starting point of our tensor transformation from gauge 1 to gauge 2, which is that this is our gauge 1 and this is our gauge 2. P caret is point here, p tilde is point here, and we are transforming a quantity from p tilde point to p caret point, and p tilde point in gauge 2 has same coordinates as p caret point in gauge 1. So our starting point will be that we write the tensor quantity T alpha beta or F alpha beta, F alpha beta, F alpha tilde beta caret minus alpha tilde beta tilde in p tilde at p tilde point minus F alpha caret beta caret at p caret point. So this gives us the transformation in perturbation from gauge 1 to gauge 2. This is in gauge 2 and this is in gauge 1. So when we say gauge 1 gauge transformation, we mean this, that how the value at p caret in caret space goes to value at p tilde at point p tilde in tilde space. Sorry. This is our starting point. This is what we have from one of our previous lectures. I will bring the caret notation back temporarily, and after simplifying all the equations, we can drop the caret and we'll keep tilde. But in order to solve the equations, it is helpful to keep caret. It's easy to visualize that it makes it obvious that caret when we are solving the equations, that we are dealing with the gauge 1 in caret space and gauge 2 in tilde space. But after simplification, we can drop caret, which means the one without caret is gauge 1 and the one with tilde is gauge 2. Okay, so we bring back the caret sign temporarily, and we write this which we derived in our previous lectures and which you can find on the review sheet also. I will share the review sheet later in one of my future videos. Okay, so caret is back, and tilde value at tilde from goes to value at caret in the same gauge in gauge 1 with the help of this relationship. And now this is my transformation equation. This is also we looked at in one of our previous lectures, that the difference in perturbation value in gauge 1 and gauge 2. So this is the perturbation value in gauge 2 minus the perturbation value in gauge 1 is equal to the value of the perturbed quantity F alpha beta f alpha tilde beta tilde at point p tilde minus f alpha caret beta caret at point p caret. So now our goal is, because we want to find this, in other words, we want to find this, and in order to find this, we need to simplify this. So this can be simplified with the help of this equation. If I write the value of f alpha caret beta caret p caret from this equation, I substitute here, then I will get this is equal to this minus the value of f alpha caret beta caret, which is, this will become so this is what we get by eliminated alpha caret beta caret p caret from both the equations, and we get this. Now what is this? This is the from alpha tilde beta. This is a value of at point p tilde. This is a value in gauge 1, and this is a value in gauge 2, and this is a value in gauge 1. So I can further simplify this, and they both values are at same point. So I can use the same point transformation relationship to further simplify this. And what is that relationship? That if I have to go from gauge 2 to gauge 1, I can write this as, this can be written as, this will be caret, and this will be caret, and here I will write x so this f alpha tilde beta tilde at p tilde from gauge 2 at point p tilde can be written in terms of its value in gauge 1 at the same point using this transformation relationship. And what is x alpha tilde mu caret and x nu caret beta tilde? Now let us write the values for these. Let's copy this equation here. And let me see if I have the values on my formula sheet. I think I do have. So on the formula sheet, do we have the values? Yes. So when you, with tilde on top and caret at bottom, I have this relationship. So this is the relation with tilde on top and caret at bottom. Mathematica editor sometimes gives trouble, but period of time I have learned to deal with it. There you go. Okay, this is better now. So I have this will be mu here, escape mu, and then alpha, and then this is nu here. Okay. Okay. And with caret on top and tilde at bottom, I have the minus relationship. So I can copy this and fix the indices and put the minus sign here. So I have nu at top. So this is alpha mu, and this is alpha mu, and this is nu. minus nu beta, nu beta, nu beta minus nu beta. Yeah, this looks good. And now we can drop the second order terms and keep only the first order terms. And we learned in the last exercise how to do that. Delta alpha mu with delta nu beta, we can keep that term. Okay, so there are total 4 terms here. This and okay, delta alpha mu with delta nu beta we can keep. Delta alpha mu with xi nu beta, this can be alpha mu. Do we need this or can we drop this? We can keep this. This is first order, so I can keep this term delta alpha mu minus this, so I can keep alpha mu minus this. Okay, so this is a second term. Then I can keep xi alpha mu with delta nu beta, so I can keep plus xi alpha mu and xi alpha mu with xi nu beta is second order, and this can be dropped. This is small change of xi alpha with respect to mu, small change of xi nu with respect to beta, and we have seen this in the previous exercise also, that this is second order and this can be dropped. So these are the first order terms that we need, and now we can further simplify this equation. Okay, so when I bring this over here, when apply this contraction, delta alpha mu with f mu nu, so mu when contracts, this mu will be replaced with the alpha. So let's apply this one by one. Let me bring it over here like this, then like this, and then like this. Okay, now one by one I can apply the contraction. So this becomes alpha here, this becomes beta here, and this is gone. Now here alpha mu will contract to, okay, so this becomes like this. Okay, and then you have this nu contracts to beta. So this is gone. Now further simplification of this. This and this, they cancel each other, so we are left with transformation of perturbation from gauge 1 to gauge 2. is equal to this value. And I can remove the brackets here. Okay. So this would become, yeah, we can further simplify this. I want to write this in the form of background value plus delta F alpha nu. But in order for me to write this in that form, remember that this P tilde has to be P caret, because when we originally wrote the perturbation equations, they are like this: F alpha caret beta caret at P caret is equal to F bar alpha beta at P point plus delta F alpha beta, and then F alpha tilde beta tilde at P tilde is equal to the background value at P plus delta F alpha beta. So in order to write this thing into this form, I need to have this point equal to P caret. So this has to be P caret. Now how I can make this P caret? I can use this expression and replace this with the value of P caret. So this becomes P tilde. I want this to be P caret. Now I can write this as the background value, this term as the background value plus perturbation in caret space. So I can write this as the background value F alpha beta P plus perturbation in caret space plus perturbation in caret space plus perturbation in caret space. You see, sometimes Mathematica editor is so much annoying, but over a period of time I have learned to have fun with it. So now you see that this is very small, this is very small, and this is very small. So if I drop the second order terms, these two will be gone. And I will be left with this. Something not right with the indices. Yeah, this has to be new. The beautiful part of typing in Mathematica is that you don't have to rub and you can copy paste all the complex equations. So this will be alpha, this will be new here. This will be, it's easy to fix. Alpha, 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 new. And I can simplify by deleting p. It is obvious that the background value is at p. Think I made one more mistake, that when I split this into background value plus perturbation, background is with the bar on top. It is this. I'm not scared of this monster. It's easy to fix. There you go. So indices look fine now. Alpha, beta, new contracts, alpha, beta, new contracts, alpha, beta, alpha, beta, alpha, beta, gamma contracts. Okay. So now, similarly, when you write this, transform from p tilde to p caret in gauge 1, you can do that with this equation. Point mu caret and b caret are our indices. Mu caret and this is mu. And this is again, you split it into background plus perturbation. Split this into background plus perturbation. We have mu and beta. 1 second. Here also it was new. Yeah, sometimes, with copy paste, you don't pay attention to indices, which is bad. We should pay attention to indices. So new, even though we are going to drop these terms. Yeah. So here we will have mu beta. So this is mu beta. Our indices are mu beta here. Okay. So bottom we have beta. Bottom we have beta. Bottom is beta. Don't want to keep this p. Okay. Bottom is beta and on top I have mu. Mu. So mu beta, mu beta, mu beta, gamma contracts. Fine. Now from this again, second order terms can be dropped. This multiplied by this is second order, and xi gamma multiplied by xi alpha with respect to mu is second order. So the only term survive will be the background here. This multiplied by the background. rest everything is gone. Okay. This is F bar here. Okay, looks good now. Perturbation transformation is given by this expression. And I can write this as like this. And now I can drop the caret. The one without caret is gauge 1, one with tilde is gauge 2, and the one with bar is FRW coordinate system. That's it for this lecture. In the next video, we will look at the various components of this rank 1 perturbation. We'll look at 0, 0, 0, 0i, I0, and ij components. Thank you for watching this lecture, and continue your progress in cosmology. It's fun. See you next time. Bye.